Yeah, everything's fine, and we're live.
Sure.
So with that, welcome Anandaganesh, Balakrishnan. Um, I'm really excited to get a little bit more of an understanding of what you do at American Water. You're a principal software engineer focused on data and AI engineering, and yeah, um, I wanna understand how your experience holding senior leadership roles across fintech, biotech, and utility has shaped your views in this current job role. Um, yeah, I'm excited to learn from you.
Sure. Hey everyone, good morning. Welcome to the AI Tech Symposium. This is Anandaganesh Balakrishnan. I work as a principal software engineer in the data engineering and AI department at American Water. I have around like 17 years of experience in the data engineering and database development space and fintech, biotech, and utility domains. My expertise is creating scalable and reliable data platforms for advanced data analytics, quantitative research, and machine learning. Currently, I'm doing research on LLMs and how it can be used to gather insights from unstructured data and how it can be utilized to generate catalogs for self-service data analytics. Today's session, I'll be talking about RAG, retrieval augmented generation, and LLMOps for database task automation and data architecture selection. Also, we'll be talking about SQL agents and chains where it will be used for automating certain tasks. So, this is the table of contents where I'll go through a few database development, database maintenance tasks, and how GenAI can help in automating a few stuffs, and what are the key data architecture patterns used across the enterprises, and how a typical RAG pipeline looks for database development, and vector embeddings related to that, and how prompt management can be effectively utilized to get accurate output, and how LLM ops can be leveraged for the entire database development where entire thing comes together, and how RAG can be done using like PDFs. So if in this example, I'm using PDF, but then it can be anything, any documents or video, audio, and how SQL chain and SQL agents can be used to generate queries to automate tasks like gathering stats, and how Langsmith can be used for RAG evaluation, and what are some of the other use cases where GenAI can be used apart from database development and maintenance to control. So, with respect to database development, there are some certain key tasks where developers do. To start with, it's requirement analysis, where if you take in a particular year, there will be like 3 or 4 releases, and within each release, there can be a bunch of CRs, 20 CRs or 15 CRs. CRs is change requests, and for each change request, there will be an impact analysis and deliverables, which will trickle down to the actual technical components. There can be conflicts within a change request or within the either it's interchange request or intra-change request. So those kind of conflicts can be identified using GenAI if the components can be provided into the models. And the other area where GenAI can help is creating the conceptual model based upon the business requirements, like what entities has to be there as a part of database schema, and yeah, eventually the logical model, and from the logical model, how the physical model, the actual table scripts, index scripts can be created using GenAI. And developers use a lot of packages, function, procedures to move data, to do data transformation, how optimization can be made by utilizing the best practices for a particular database, like maintaining idempotency and creating deterministic functions, and how to create functions and procedures for bulk data loads. And GenAI also can help in like query generation and optimization by gathering stats and updating the metadata. And other task is like data cleaning and data transmission, where it can generate and create scripts. With respect to database maintenance, there are a few key tasks like backup and recovery, how to automate backup schedules, monitor backup processes, and predict failures in case of if anything goes wrong. And with respect to the performance tuning, continuously monitor the queries, long running queries, and suggest optimizations based upon the data access paths and the query plan which the engine is taking, and create some indexing strategies based on the best practices. With respect to security management, identify are there any vulnerabilities within the database, whether the proper permissions has been set for the users, whether are there any proper role-based authentication is in place, are the data within the database is encrypted, those kind of things. And for database monitoring, provide real-time monitoring and like detecting anomalies. There are a lot of ML and AI algorithms to do the anomaly detection and do some cool predictive analytics. And statistics gathering, which I've touched upon earlier, updating. It's all about updating the metadata and data catalog creation and validation. AI can really help in this arena to create the data catalog so that the less technical savvy users can read their catalog and then can query the data and get the desired results without learning the technology. And it also can help in upgrade and patch management, like recommending optimal patching schedules and generating patching back report. So some of the key architecture patterns which are used across the enterprise is ELD or ETL pattern, where the transformation happens, right? And the Lambda architecture, where it has both the batch component and real-time component, like as I mentioned in this picture. And the Kappa architecture has just the real-time component, and the Lakehouse architecture has it's a kind of combination of data warehouse and then asset properties, and the medallion architecture, which has different layers like bronze, silver, gold, where raw data goes into like a bronze layer, and then the transformed data goes into silver layer, and the aggregated business data goes in the gold layer, where the business users can query. So this is kind of the best practices for each of the data architects can be utilized for RAG to generate or recommend data architecture for a particular business requirement and for a particular constraint. So how a simple RAG looks for, especially for database development. So uh, the developers or subject matter expert can create a document for database development best practices, be it any database like RDBMS like Oracle or NoSQL like DynamoDB. That document can be fed into a vector database by splitting the document into chunks and creating the vector embeddings and storing it over there. And a junior developer or any user who does not know about the database development can query using a prompt, and that goes into the vector database to get top k information by similarity search. And so the top k documents along with the user query and prompt is fed into LLM to generate a relevant response. So how the vector embedding scenario looks like. So the documents can be there as a blueprint, an image, or it can be in a document or PDF, or it can be in like a podcast on vector DB selection or database best practices video. So it can be fed into appropriate models like image model, document model, audio model, and video model to create relevant embeddings, and then it is fed into the vector database. For example, like AWS Bedrock operates similar to this, like where they have created, uploaded all those best practices into embeddings, and the automation happens from there. So why prompt management is important? Because if the prompts are wrong, obviously the response might be bad. So few prompt techniques which is used across enterprises are like one is like how much context is given into the LLM, like zero shot or a single shot, few shot, or many shot, and how the prompt types are being given. Like either it is given via like a template, like prompt template, or a series of prompts, like chain of thought prompts, or explicit constraints can be mentioned along with the prompts so that uh, to elicit accurate response. And there are some other prompts, but we'll be focusing more on this prompt template in the upcoming slides. So how the overall picture looks for LLMOps, it's a combination of RAG, prompt template management, and the data and model observability, where observability needs to be done at each stages to monitor whether the response or whether the output is according to the standards or according to the expectations. So there are a lot of data observability tools available like Datadog and Datafold, or custom scripts can be used to monitor the result of the retrieval from the vector database or the output from the LLM, or the how the different prompts are giving responses. So it can be done across the stack. So I'll be showing a small demo on how like a RAG is created using PDF and how some of the database tasks can be automated, like SQL generation and statistics gathering. So these are the tools, framework, and models which I'll be using. For the framework, it's LangChain, and for the large language models, it's Llama 3 and GPT 3.5. And for storing the embeddings, I'll be using ChromaDB for the and it'll be a local RAG. For embeddings, low llama embeddings for RAG, and for chains and agents, it's SQL database chain and SQL agent. And for the database, I'll be using MySQL to show you a little demo. So how a RAG is creating using PDF. For example, I've chosen this key factors driving data architecture selection. This PDF is loaded and it gets split using text splitter. And one, it is split the vector embeddings done using the Olama embeddings, and it is stored in the ChromaDB store. So once a user queries using like a query, like what are the key things that needs to be considered before selecting the data architecture, it goes through the chain where it retrieves the relevant data from the vector store, and it gives you the response to the user based on the query. So this is one such example. Like I've asked this question, like what are the key things that are needs to be considered before selecting the data architecture? Once the chain is executed, it provided me this answer, like according to the provided PDF, the key things that needs to be considered before selecting the data architecture are the data size, it can be the data frequency, how often the data comes inside, and what are the data source locations, and like how urgent is the solution to implement. Is it like a one-time solution, or it has to be a persistent solution, or based upon the architectural affinity. So whatever the data which has been given in the PDF, it gets contextually grounded and it throws. So this might not be correct, needs to be validated. There's another question which I asked based upon these best practices MySQL performance optimization PDF. Like, what are some of the best practices for suppose index creation in MySQL? And it gave me this response like create an index for fields that the users use to search often, and use indexes like when joining tables, create indexes based on the joining columns, and it gives some other suggestions as well. It's up to the developers to use a particular suggestion or all the suggestions, and these suggestions needs to be verified before implementing. One another question which I have asked is like, which is the best database that can be used for caching and why, based upon this PDF, and it has given me the response like based on the context provided. Redis is the best database for caching due to its extremely fast performance, thanks to its memory storage, and other characteristics related to the Redis database. So, what are agents and chains for MySQL database tasks? So, at high level, both SQL chain and agent, it converts the user input into the SQL query, and it executes the query, and the model responds the user for the user input using the query results. So SQL agents can be used to address use can be used for query generation or describing some specific table within the database. The good thing about agent is if you provide a wrong table name, like if you just put a plural instead of a singular, it still can recover and from the errors, and it can try to get the closest table name possible. But it is a double-edged sword, so it can give you some wrong table as well. But then the good part is it won't fail immediately. It retries and gives you the best response as possible. The SQL chains are a little bit more rigid. It throws you an error if something is not present. Uh, can be used for like creating chatbots that can answer questions based on the database data, or it can be used for building custom dashboards based on the insights user wants to analyze. So I'll be showing you a small demo for some of the queries for MySQL database tasks. So in this script, so I've created a schema. This is MySQL database. I've created a schema called employees. And there are like few tables like department, department employee, department manager, employees, salaries, and titles. And I have connected to the database, and we'll be using LLM ChatGPT 3.5 to elicit response. So I have created a database chain based upon the MySQL URL over here, and here is the prompt template which will be used once the query is input to the LLM model. So this is a query. So who are the employees that start with letter G? List only 5 employees. And once we execute this query, it will start a chain, and it prints you the actual SQL query and the result. So since we have asked only top 5, it's going to give only the 5 rows. So what I've done is I've also included like the cost involved in executing the query. So you can see some cents over here, so that can be monitored, and how many tokens are being used, how many number of prompt tokens, and how many tokens model also like augmented to create the output. So this query can be just selected and then can be run in the database. See, so it runs fine. So it picks up the 5 rows. So the other query which I've asked is how many employees there are with the department finance. If you run this, it's gonna start the same database chain, and then you can see the select count start from, and then it picks, and then it gives you there is like 17,346 employees that are in the finance department. One another is like generate an update statement if the user wants to update a salary of a particular employee between the dates. So if you see for the same salary for the employee, if you can see the salary is 61417, and if I run this query, it creates an update statement. It also updates. If you see the cost, it's a little bit more than select the update statement. Now if you query the data. You can see like, yeah, it got updated from 417 to 517. It got updated. Um, so the other one which I would like to show you is how to gather statistics for a particular table. So here I've asked analyze the table departments and gather statistics and execute the analyze statement. If you see in this table departments, we have around like 12 rows, and I'd like to show you the statistics. If you see the statistics, it's 12 rows over here. And if I want to insert a new row, I have inserted a new row for departments. And now it's 13 rows, right? But the stats are not yet updated. It's still showing 12. So if I execute this, so it analyzed the table, and the analyzed table for analyzed statement has been executed successfully. And you can see the cost for that as well. If I see the stats for now for that, now it has been updated to 13. So this metadata is important, especially for the query engine to pick the right data access paths. So this is a simple example, but then the complicated examples can be incremental stats gathering and full stats gathering depending upon different scenarios. So, but what if you want to just generate queries and without executing it? So it can be done using the create SQL query chain, where you provide the same set of prompts and it's going to give you just the queries. So I have created similar set of prompts, as well as in the last prompt, I have asked it to create a schema itself, a normalized schema for 3 entities. You can see, yeah, so it has created, let me run it again. I think it should, for some reason, it's not giving the response 5. But it has created a normalized schema for these 3 entities with the primary key, foreign key, and the indexes. Okay, so this is via the SQL database chain. And how agents can be used. Agents is a little bit sleek than chain, where you give similar set of parameters like the database URL, and you create an agent executor using the create SQL agent with the LLM DB. And verbose is true set to see the intermediate results. And agent executor can be invoked using this command with the prompts, with the user queries. So it creates an agent executor chain, and you can see the queries, and it also gets executed. And you can see the output as well. Yeah. So back to the slide. So a RAG has advantages, but has its own disadvantages as well. Still, hallucination can happen. So there are possibilities to update the documents. Either it's a chunk replacement or the whole set, or using prompt engineering. Appropriate prompt can be given to add more context to elicit accurate response. There's another strategy which organizations are using is advanced RAG with self-correction, where during the retrieval of the document stage, the relevance of the content is measured. And appropriately, like a hybrid search can be done, RAG and web search, if it is not a private information. And agents can do the web search for relevant documents, and those documents can be appended to the vector store. This loop can be repeated until the desired accuracy is reached. There's one more tool which can be used for evaluation, is Langsmith, which I'll be discussing in the next slide. Langsmith is another framework similar to LangChain, which can be used to actually measure the relevance of the output which is elicited by the RAG. So typically, there are like four types of RAG eval, which is done using Langsmith. Like the response versus reference answer, like how similar or correct is the RAG chain answer relative to the ground truth. There is a truth which the developers know that can be compared with the response. Between the response versus input, like how well the response compared with the initial user input, the query, and the response versus retrieved docs, like to what extent like does the generated response agree with the retrieved context. So these are different perspectives, like retrieved docs versus input. Like how good are my retrieved results for the query and the prompt template which the user has provided. So I do not have code for this, but then there is extensive documentation within the for the Langsmith framework where the developers can utilize. So there are other use cases with RAG, especially these are synonymous, or this is done along with the database development, like the data warehouse design, how the dimensional modeling can be done, like Snowflake, creating Snowflake schema, star schema, how data visualization design can be made using the mass MPP, which MPP needs to be selected, which caching database needs to be selected, which vector DBs can be selected in the logical layer of the data visualization, and how data catalog can be created for self-service data analytics, which will really help the business users. And for domain-driven data modeling, how data mesh can be created using GenAI, and for end-to-end data integration, how GenAI can assist data fabric creation. So these are the latest things which organizations are working on in automating certain things using GenAI. So in the future, LLM agents will play a very key role along with RAG in automating stuffs. And I believe the presentation has helped you in how LLM and agents and chains can be used to automate database tasks.
Yeah, thank you very much for breaking down how to build a multimodal understanding of your enterprise, all the knowledge, and how to provide structure for agent to sort of pick out the pieces that are relevant to provide a contextualized response. Um, so, have you? What are the next steps in applying this as a use case or embedding this in a workflow?
So in our organization, we use AWS. It's AWS heavy. So we are going to utilize AWS Bedrock for RAG use case, as well as like using multimodal embeddings, where you can just embed all those data architecture blueprints, or can be anything, right? Can be video, audio, anything. So there are a lot of models which is available within Bedrock, like Mistral, right, Anthropic, Claude. So we are going to leverage RAG using Bedrock.
And what is the expected outcome for?
The expected outcome is automating certain things, like within our ETL processes, to identify bottlenecks, right, and what a performance optimization can be made based on the AWS best practices. So AWS has this well-architected framework, whether the data architecture within the organization is in line with the well-architected framework. So those kind of evaluation can be made using this.
And this is going to help observe or evaluate the operations within American Water.
This is
Like,
Yeah, yeah. This is going to see. So we have a 2030 initiative which is going on, and we are not going crazy immediately. We are evaluating what is the current architecture, and then slowly we'll incorporate AI elements into it, because there is still a lot of challenges like hallucination and other things, right? Might do some wrong things as well. So we need to measure at each steps to rectify it, and it will be an iterative process.
this is the internal proof of concept that once you validate and understand the lessons, you're going to start rolling out and select pilots, right?
Exactly. So whichever works good, we are going to select. We are going to pick and choose.
Okay.
So it's not going to automate everything. Certain key areas, like whether we have chosen the right tool, right? Whether we have chosen the right architecture. So those high level decisions can be still be utilized using it.
Excellent. Well, if anybody wants to learn a little bit more about what's not covered under the NDA, reach out to Anandaganesh to have a conversation. I'm sure you can compare notes. And yeah, thank you very much. We're gonna take a short break, and then we're gonna go on to the next one. Yeah.
Thank you everyone. Thank you again.